In this exercise, we're given a particularly complicated equation from physics, and we have to find a particular derivative. First, we need to figure out what exactly we're looking for. At the end of the problem, you can see that it asks you to find the rate of change of the volume with respect to the pressure. And what that means is we're looking for dV, dP, V on the top, P on the bottom. And what that means is that we're supposed to regard V as a function of capital P. This means that P is an independent variable, we get to choose it, and V depends on P. V is a dependent variable. Both of them are changing. We need to look at the other letters or variables in this equation and classify them. They could also be dependent variables or independent variables. But when we read the problem, we can see there are some clues here. R is a universal gas constant. A and B are positive constants. The problem even says that the temperature is going to remain constant. So we are supposed to regard all of these letters as unchanging constants. They are not going to be any kind of variable at all. That leaves N. At the very beginning of the problem, it says that we have N moles of gas. We're supposed to understand that the number of moles of gas is not going to change. So N is also going to be a constant. So now I'm going to take the derivative of this equation with respect to P. I'm going to use implicit differentiation. And what that means is taking ddP of both sides. It helps here to remind yourself which letters count as variables and which count as constants. I've highlighted all of the P's and V's in this equation. Everything else is to be regarded as a number. On the left, I'm going to use the power rule. And so the derivative of P plus n squared A over V squared is 1 minus n squared A over V cubed dV dP. Can you see that I used implicit differentiation, or the chain rule, on that V squared in the denominator, times V minus NB. And then the second half of the product rule, I add P plus n squared A over V squared times the derivative of V minus NB, which is just dV dP. On the right-hand side, we have N times R times T. All three of those are constants. So the derivative with respect to P, just 0. Next, I need to work on isolating dV dP. And so what I'm going to do is distribute all of the terms on the left-hand side so that I can gather up every term that has a dV dP in it. Notice, though, that there are two terms that match and have opposite sign. They're going to cancel. I have two terms with no dV dP in them, so I'm going to subtract them and move them to the right-hand side of the equation, and I'm left with two terms that have a dV dP in them. I'm going to factor out dV dP. Notice I have NB minus V on the right-hand side now, and I'm going to divide by that factor, and I get my final answer. The moral of the story is it's often helpful to explicitly label your independent and dependent variables and constants. Make a list in the margins, and it will help you keep your problems straight.